We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Hey guys, let's go over skills practice 512, letter B, the introductory. Okay, let's just do some basic definitions again. Right here in the middle of a normal curve is something called the mean. And we've talked about previously in a previous video, this is the mean for the population, and this one is called a sample mean with X bar. And then we talked about how standard deviation is here in green. Standard deviation. It is a measure of, they call it spread. How far apart is the data from the center? So I'm just going to call that spread. And in the blue, mean is a measure of the center. Okay, I'm going to talk about the empirical rule, but before I do that, I want to mention one idea. Area under the curve equals 1. So basically we talked about this ghost, right? And if you shade this all in, that is equal to 1. Okay, so the big one is called the empirical rule. And in the empirical rule, 1 standard deviation, remember -1 standard deviation, the symbol for standard deviation is here with the O with the little tail, and positive standard deviation. Positive just means you're going towards the right. Is this area. Alright, so this whole area is a total of 68%. Let me shade that in with a yellow. So everything that I'm shading in here is 68%. Now, you need to know this. If the mean, the dark blue line, cuts it in half, that means each of these are 34%, because 34 plus 34 equals 68. So if I said how much of the data is 1 standard deviation above the mean, that would be towards the right, that would be 34%. If I said what is the area, what is the percentage of the area between 1 standard deviation, we talked about between is between 2 locations, that's -1 standard deviation plus 1 standard deviation, 34 plus 34 is 68. Okay, the next part of the empirical rule is within 2 standard deviations, so here again is the mean. This would be a +2. This would be a -2. And these numbers are always, so an empirical rule always, between 2 standard deviations. This area I forgot to draw the mean. So total, this whole area is going to be 95%. In red, the shaded red area. And if you divide 95 in half, you will get 47.5% each. So the left side is 47.5, the right side is 47.5, and if you add the 2 reds together, you get 95%. Now, you might come into a situation that looks like this. Whoops. Let's try that again. There's the center. And let's just say you're at if you know this blue region here represents 34%, then this green region, 47.5 minus 34 gives you 13.5. Why? Because the green area, if it's 13.5, and the blue area is 34, if you add those two together, you will get 47.5. So that, going that direction, remember, is 47.5. Okay? And let's do the last one. Let's do purple. The last one is within, from the center, 3 standard deviations. Let me count those out loud. 1, 2, 3 standard deviations. And if you go towards the left, 1, 2, 3. Basically up here. Let's shade that in some kind of color here. Let's choose green. So everything in green, this here represents, in green, 99.7%. So again, the empirical rule is 68, 95, 99.7. So let's just say you divide 99.7 in half. You divide it by 2. So 99.7 divided by 2 gives me 49.85. 49.85%. Okay, I do want to point out an area that we did not talk about is this area in red. These are called the tails. And we talked about how the area under the curve is 100%. And if I do it for this problem, let's say I subtract 99.7. That means the two tails together equals 0.3% together, the two reds. So 2 reds equals 0.3%. If you divide it by 2, you'll get one of these reds equals 0.15. So if you add up all these areas together, let me get a different color. I'll give you yellow. 0.15 plus 49.85 plus, that one should say 49.85. That's what I didn't want. No. Let's try that again. Okay, so 0.15 plus 49.85 plus 49.85 plus 15 will give you 100%. Okay? So this is called the empirical rule. So basically in the next problem set, you're going to do the same thing. You're going to do the shading of region, and then you'll use the empirical rule and kind of divide them up to figure out the estimated percentage. Look at B1, but let's read the directions. Estimate the percent of data within the specified intervals of each distribution. I'm going to use what we learned in Skills Practice 5.1.2a and do the shading first, because it says shade the corresponding region under the curve, label the tick marks on the horizontal, and label the horizontal axis. Then use the empirical rule, and then I would say estimate. Okay. Determine the percent of adult women with a cholesterol higher than 212 milligrams per deciliter. So just don't need to know that much. Yeah, given that, okay, this is important. Given that the mean cholesterol is 188. So again, the center is 188. You can put the units. And then it says with a standard deviation of 24. Okay, so that means if I add 24 here, I will get 2 extra 1, 212. And if I add another 24, I will get 236. And if I add 24 again, I will get 260. And if I subtract 24, which is really one standard deviation, right? 2 times 24, this is going to be negative 3 times 24. So if I subtract 24, I'm going to get 168. And if I keep going, 164, excuse me, double check my other numbers, 212, 236, 260, yeah, 164, subtract 24 again, you will get 140, and you subtract 24 again, you'll get negative, or positive 116. So if you were doing that by hand, negative 3 times 24 gives you negative 72. So essentially what you're doing is negative 72. Let me show you how I got that. 188 minus 72 gives you 116. Okay? So 2 ways to figure out the standard deviation going there at the horizontal axis. Okay, now we need to locate 212 degrees. 212 once higher. So last time we talked about higher is going towards the right. So let's locate 212. Okay, so now we want stuff that's higher. So basically we wanted this shaded region here. Okay, the first thing I'm going to notice is that this is at 1 standard deviation. And if you look at the empirical rule, which one of these has only 1 standard deviation? Is it the light blue, 68, orange, 95, or the purple, 99.7? Well, I'm going to focus on this one. I'm going to focus on that the middle region there is 68. Okay, so let me just do a little side problem here. Okay, this region here represents 68. Now I just need to find the yellow region. So hopefully this visual is helpful for you. Basically, you have purple plus 2 yellows equals 1. That's the area under the curve, 1. And if purple is 68, yellow is like my variable, 0.68, because that's a percent to a decimal, and we just subtract 0.68, I'm going to get 2 yellows equal 0.32. Because it's like $1 minus 68 cents, you get 32 cents. And then if I divide that by 2, I will get each yellow region to be 0.16. So if that left side is, or right side is 0.16, and this side is 0.16, 0.16, 68, and 16 will give me 100. So if you look at this red region, that'll represent 16. Determine the percent of adult women with cholesterol higher than 212, given that the mean is 180 and standard deviation, the answer is 16%. All right, B2 here says determine the percent of adults who are shorter. Let's highlight that one, shorter. So last in 5.12a, we learned that shorter is left of this marker, 63.4. We'll come back to the purple, but I'm looking at this. Given, we learned back in integrated math 2, kind of like with proofs, given is kind of like a puzzle piece that's already kind of put in place in the correct placement. So given that the average man is 69, remember when it has the word they don't tell you this, but they're implying that this is the mean. Average is another word for mean, so that's the center. So I'm going to write 69 inches. And this is our population mean. Measure of center, okay? And then the green we talked about is with a standard deviation of 2.8, okay? What that means is going 1 standard deviation above means to add 2.8. And if you pull out your calculator, you'll get this one to be 71.8. And if it's 2 standard deviations, that's basically adding 2.8 plus 2.8 from 69, or just 2.8 to 71.8, this would give you 74.6. Or 3 standard deviations, again, the math behind that is 3 times 2.8, which would give you 4 to 8.4. So 8.4 plus 69, they would give you 77.4. And then basically what we're going to do is we're going to do the same thing going towards the left. So from the mean, 69, if you 1 standard deviation below means to subtract 2.8. So if you subtract 2.8 from 69, you will get 66.2. 2 standard deviations means subtracting 2.8 twice from 69, and that would give you 63.4. Or if you subtract 3 standard deviations, or subtracting 2.8 3 times from 69, or basically 1 time from 63.4, you will get 60.6. Okay? Okay, let's go ahead and locate now that purple line. 63.4 is right here. And they want something that's shorter or to the left. They want to know what this region is. Okay, I'm going to use a color I have not used before. Let's use red. This line here represents how many standard deviations. Well, if I go from the center, this represents 2, right? 1, 2 standard deviations. So if I go back up here and I use the empirical rule, which of these shaded regions, the yellow, red, or green? Well, 2 standard deviations would be this one, 95%. So let's go ahead and use that information. And I'm going to use information like this. The region inside here is 2 standard deviations, that's 0.95. Let's do a different color, how about green? That means these 2 tails to the left and to the right, we're not sure what they are. So let's write that. 2 green plus 0.95 equals 1. That was the other main idea from the intro video, right? Area under the curve equals 1. So here I'm just going to subtract 0.95 from $1, and you will get 2 greens equal 0.05. Okay? And then if you divide by 2 here, basically means each green tail, they call them, equals, what's half of 5 cents? That is 0.025. Okay, so that means that this is 0.025, 0.025. Remember, 0.025 plus 95 plus 0.025 equals 1. Okay, so that basically means in this here, I was just trying to find this region represents this region. Does that make sense? So our answer is 0.025, which is, if you move the decimal 2 places or multiply by 100, you will get 2.5%. Let's box our answer. This is my answer there. 2.5% of the population is shorter than 63.4 inches. Let's do some shading. Use the empirical rule, and then we'll estimate the percentage. Determine the percentage of pregnancies with a duration between 253 and 283 days given, okay, we've been using the color blue for the mean. So it says the mean is 268. So mean is equal to 268, and you could put days as our unit. Then in green, we've been using standard deviation, which is spread, which means 15 days. So plus 1 standard deviation. So in some ways, I want you to think about it is, so if I add 1 standard deviation or add 15, I will get 283. If I add another 15 days, or 2 standard deviations, or 268 plus 15, that'll give me 298. Or 3 standard deviations would give me 313. Remember, those were positive. Negative standard deviation just means going towards the left. So instead of adding 15 from the mean, we're going to subtract 15 once. This would give me the number 253 days. If I subtract 2 standard deviations, is subtracting 2 15s from 268, you will get 238. And 3 standard deviations basically means you're subtracting 15 from the mean 3 times. And this would give you 223. Okay, let's locate 253, 283, and it wants the between. So basically all of this. Okay, now if you look at this problem, 253 and 283 are how many standard deviations away from the center? Now, the common mistake is to say 2. Okay, we would not say 2 because you might think 1, 2. That's wrong. We would actually say it's only 1 standard deviation away, positive or negative. And remember our problem here in yellow, which is the shaded region from this one? Is it the far left, middle, or the right one? Well, only the far left one here has 1 standard deviation, so that would be 68%. And I'm just asked to find that yellow region, so the answer is 68%. What percent of pregnancies with a duration between 253 and 283 days? That is 68%. Ironically, right, my wife is pregnant. I wonder how close she is to that one. That's B3. Let's try B4. Determine the percent of people that have an IQ greater than 145 with a mean of 100. So mean is a measure of center. It's going here in the center in a normal symmetrical. That is a 100 IQ score. And a standard deviation of 15. Remember, standard deviation basically means a measure of spread. Like the blueberry jam was placed right in the middle or center. And if I add 15 to 100, this gives me 115. Again, where did I get that 15 from? That is it tells us standard deviation is equal to 15. Okay, if you add 2 standard deviations, you're kind of adding 2 15s to the center. So 100 plus 115, that would be 130, and you can just 145. You're just counting by 15s there. You remember that how this one works is 3 times the standard deviation, which is 15, which is 45. So that would be 100 plus 45 would give you that. 100 plus 45 would give you 145. So that's another way of getting those numbers. We're going to do the same exact thing. Now we're just going to be subtracting 15. Why subtracting? Because going towards the left is negative standard deviations. And we just, subtract 15 each time. This would be 85, 70, and 55. That way you realize on the horizontal you're just counting by 15s. Okay, let's go ahead and find 145, which is over here. And this one wants greater, which means we learned previously that means going towards the right. They want to know what this yellow shaded region is. Okay, so we have to connect this to the empirical rule. The question is, how many standard deviations is this away? Well, you can just count. 1, 2, 3. 3 standard deviations away. right there, right? So if you look at the empirical rule, which one has 3 standard deviations? Is it the yellow, red, or green region? Well, it's the green region because it says there 3 standard deviations away. So that green region is representing 99.7. 99.7. So this whole region here represents 99.7, or point, that's percent, so 0.997. And how do you get this black region? Well, I call it 2 blacks plus the red region, which is 0.997, equals 1. That's a big idea. The area of the curve equals 1. So if I go ahead and subtract 0.997, put that in your calculator, you will have 2 black regions or tails equals to 0.003. And then if you divide by 2 here, you get each black region to equal 0.0015. Now they did want a percent, so let's do this first in decimals and percents. So 0.0015 is 1 black region. So if you add up the numbers 0.0115, 0.997, and 0.0115, it'll equal 1. If you do this in decimals, percents, you would go from a decimal to a percent, you multiply the number by 100. If you do that, you can just move it 2 decimal places, and you'll get 0.15%. And this is our answer. Right, because this right here, 0.15% plus 99.7 plus 0.15% will equal 1. That is our answer for B4. Let's go ahead and try B5. Determine the percent of students who will get a grade between 80.9 and 86 on an upcoming math test, given that the professor's tests are normally distributed with a mean of 75.8. So 75.8 score on math test, and a standard deviation of 5.1. Okay, let's just go towards the right. This is 1 standard deviation, which means I'm just going to add 5.1, and this will give us 80.9. If you add 2 standard deviations, or adding 2 5.1s to 75.8, you will get 86. And 3 standard deviations, which is adding 5.1 3 times to 75.8, you will get 91.1. Let's go towards the left, and all we have to do is keep subtracting 5.1. This would give us 70.7. You subtract 2 standard deviations, that's kind of subtracting negative 5.1, negative 5.1, and you will get 65.6. And 3 standard deviations, you will subtract 5.1 and get 60.5. Okay, so that's labeling the horizontal with our units. Okay, let's go ahead and locate this one. 80.9 and 86. Okay, so I want to know between, so I want to know this region in yellow. Okay, in this problem, we're going to have to use 2 numbers. The worst thing you can do is just subtract the horizontals. Because if you subtract the horizontals, that's adding like how many, what would the test score be? Well, we're trying to find the area under the curve, which is the yellow. So notice how this is 1 standard deviation away and this is 2 standard deviations away. So in this problem, I'm going to have to use 2. Let's do one of these in blue. And the other one, well, I can use the colors above that we did, yellow and red. So 1 standard deviation is going to be 68%, and divided between 2, that's 34%. And over here, between 2 standard deviations is 95 or 47.5 on both of those. Okay, so I'm going to copy that information down for our problem. Okay, so we said that this was going to be 68. That's 1 standard deviation. And this represents 68%, and we cut each of those in half, 34. Okay. On the other side, we said that between 2 standard deviations away from the center, we said that this green inside there represents 95, or 47.5 each. So we cut 95 in half, you have 47 in half and 47 in half, okay? Okay, so I'm gonna highlight what we need. We need, let's do this one yellow, watch. This region right here is 34%. And I'm gonna color that in here. Because you guys think about it, this is the mean, whoops. This is the mean, black. This is the mean. Right there is 1 standard deviation away. And that yellow only represents, pay attention, that was only 34%. So 34%, and this X region equals 47.5%. Or turn it into a decimal is 0.475. So 0.34 plus X equals 0.475. Let's give you a visual. This red region, yellow, so let's just, yellow plus red equals 47.5. Yellow plus red equals 47.5. The reason why this one does not equal 1 anymore is because they wanted us to get that small sliver. So again, it was 2 standard deviations away, and we want the, just that, I guess I can color it in red here. So this is what we have so far. The red region, we're trying to find out. The yellow region we know is 34%, and the yellow plus red equals 0.475. Let's go ahead and finish up the problem. So if I subtract, don't want to write with highlighter, come on. There we go. You will get a value of X equals 13.5. 0.135. And again, if you want to make this a percent to a decimal, you just multiply by 100, you use your calculator, or just move it over twice, and you get 13.5% is our answer. That red region equals 13.5%. Let's review. 0.34 plus 0.135 equals 0.475. In order to do this problem, again, I had to use the empirical rule, both the 1 standard deviation, which is 68%, and the 95% one. Guys, let's go over B6. Determine the percent of adult males who weigh more than 153 pounds, given that the mean, so we've been using the mean or the center with the blue color, 173 pounds. LBS is the abbreviation for pounds. Standard deviation. Deviation is a measure of spread. It has a little O with a little tail on it. That is 20 pounds. So 1 standard deviation means to add 20. 2 standard deviations means to add 20 twice from the mean or the center. So 193, and then this would be 213. And 3 of these standard deviations are adding 3 20s to 173 would give us 233. And then we do the same thing going towards the left. We're just going to subtract 20. So this would give us 153 pounds. Subtracting 2 20s from 173 would give us 133. And 3 of these means subtracting 20 3 times from 173, that would give us 113. Okay, let's locate 153 pounds, and it says more, so that means we want to shade going towards the right. Here's 53, and basically we want to find this yellow region. Okay, the trick to finding this one is to applying the empirical rule. And the line that you have, not the mean, not the blue one, the yellow one, this represents how far away, how many standard deviations away from the center. The answer is 1 standard deviation. Okay, so if I go back up to the empirical rule, which one of these represents 1 standard deviation away? The left, middle, or right? That would be the left side. 1 standard deviation away is 68%, or 34 and 34. So I have this 1 standard deviation away, and this area represents 68% of 0.68. So we can say that the green tails 0.68 plus 2 green tails equals 1. If I subtract 68 from 100 equals 2 greens equals 0.32. And if I divide by 2, that means each green tail is going to equal 0.16. So 0.16 plus 68 plus 16 will give you now 1. So each of the green tails is 1. So basically, if you think about it, what I just found on that side problem above, I can now apply here. This green region represents 16. So you can think of it as, let's say, we did this problem first, then we kind of did over here second, and then third, we're kind of using this idea over here, okay? So I have the green plus the yellow. So green plus the yellow equals 1, right? Oops. And the green we said was 0.16. And we're trying to find out what the yellow is. Let's call it x. So if I subtract 16, how do you make 1 a decimal? You just put decimal and point zeros on it. So you have $1 minus 16 cents. You're going to get x equals 0.84. Multiply by 100, or just change it, move it over, you get 84%. This region here represents 0.84, right over here, 0.84, all that in yellow. So our answer is 84% of adult males who weigh more than 153 pounds. So majority, right? 84 is a lot. All right, let's go ahead and go over B7 here. Determine the percent of students who score between 390 and 590 on the verbal section of the standardized test given, okay, this is what I want, the mean is 490. That's just mu, or a symbol for the mean. And a standard deviation of 100. So plus 1 would mean adding 100. So that would give us 590. 2 100s would give us 690. And 3 standard deviations, adding 3 100s would give us 790. And then going towards the left, you just subtract the standard deviation. So 390, 290, and 190. Okay? So those are our IQ scores. And they want to know between 390 and 590. Well, how many standard deviations is this away? Okay, pay attention. The answer is not 2 standard deviations away. We like to say 1 standard deviation away. 1 standard deviation away. So, if you apply the empirical rule, excuse me, is it the yellow, red, or green? 1 standard deviation would be this number right here. So we just have to go over here and we want the red region. Well, guess what, guys? The answer is 68. We didn't have to really do much on that one. Pretty easy. All you have to do identify is it's 1 standard deviation away. Again, how you're going to know that is just looking at that number. You don't add both of them, just 1 standard deviation away. All right, let's go over B8. Determine the percent of players who score more than 155 points in a crossword puzzle given the mean is 141. Mean 141. Score on cross. I can't even spell cross. Word puzzle. Okay. Then it says the standard deviation, or the measure of spread, is 7. So going towards the right is positive. So this would be plus 7, which would give us 148. 2 standard deviations away would give us another plus 7, so 155. And 3 standard deviations away would give us 162. To go below, or negative standard deviation in some ways, we subtract 7 from the mean, which would give us 134. Subtract, which would give us 127. And subtract 7 again, or subtracting 7 3 times would give us 120. Okay, so now I need to locate these numbers. More means going towards the right from 155. Here's 155. And they want to know what this yellow region is. And let's color this left side. Let's do green. Okay? Did I get all that? Crosshash. It's kind of fun, coloring, shading, right? Kind of messy, sorry. So yellow plus green equals 1. Yellow, green plus yellow equals 1. But we have to apply this to the empirical rule. So the question is, from the yellow region, the yellow line, how many standard deviations away is it from the center? Well, hopefully make this obvious, or hopefully you understand it. It's 2, right? Let me count them. 1, 2. Okay? So let's go ahead and look above. Which one is it? Yellow, red, or green? It's going to be the what? The red region. The red one here has what? What does it have down here? 2 standard deviations away. So we didn't need to know that between 2 standard deviations, it's 95% or 47.5 for each. So let's just put the empirical rule here. You just have to memorize those numbers, right? 68, 95, 99.7. And let's call it the blue region. This blue region represents 95. And basically we need to figure out the 2 yellows. So 2 yellows plus the blue equals 1. The blue represents 95. And I can subtract 95 from both sides. Remember, this is 1, so I have 2 yellows equals 0.05, and you can use your calculator, divided by 2. You will get each yellow to be 0.025. Okay, so let's use that information for this one over here. We just said that a yellow region, one yellow region, because over here this was 0.025, 0.025 each, right? Because if you add those together, you will get 1, so 0.025. So the question is, how much is the green region? You can call it X. So we just subtract. So X equals 0.975. Nope, I was wrong. I reread the problem. And here, this is great. This is great that I made a mistake. I didn't do this on purpose. I just realized it. It says more means towards the right. And which one's bigger, green or yellow? It's the green region, but how can you have 0.975? So that's all I wanted to know. The answer is 0.025. This is your answer. I did not actually need to solve for X. I'm just solving for the yellow region. If you wanted to solve for the green region, you can just add, you can just add these two numbers together, right? But all I wanted to know was the 0.025, and that was B8. See you guys.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today.